Let's look at this problem. Hiram's algebra notes are 50 pages long and are printed on 25 sheets of paper. The first sheet contains pages 1 and 2. The second sheet contains pages 3 and 4, and so on. One day, he leaves his notes on the table before leaving for lunch, and his roommate decides to borrow some pages from the middle of the notes. When Hiram comes back, he discovers that his roommate has taken a consecutive set of sheets from the notes, and that the average of the page numbers on all remaining sheets is exactly 19. How many sheets are borrowed? This is a quite interesting problem about average. So as long as you understand the definition of an average and some basic techniques to solve problems related to this, it should not be too hard. However, depends on what comes to your mind in the first place in the exam. The calculation part can differ quite a bit. So in this video, I'll introduce two ways to solve this problem. The first way is somehow tedious, but the idea behind it is still straightforward. And the second way is still to apply the definition of an average. And it's a more standard way. And the calculation part is a lot faster. It can save you quite some time in the exam. Therefore, if you are just interested in the fast way, you can skip the first part of this video. Alright, let's get started. So the first method, let's call that M1, method 1. In this method, after you read this problem, if the first idea that comes to your mind is about the page range, then you should set some variables like this. So let's assume, so we think about the page or the page numbers. So assume page N1 up to N2 are borrowed. Right? Pages N1 to N2 are borrowed. And therefore, we know that N1 shall be an odd number, and N2 shall be an even number. And these facts are directly from the example, right? We know that the first sheet contains page 1 and 2. The second contains 3 and 4, and so on and so forth. However, this fact may not matter that much, and you'll find out in our following analysis. Given such variables, we shall know the pages that's been left on the table should be like this. They are divided into two parts. So let's say this is pages left. We have two parts. The first part is from page 1 all the way up to N1 minus 1. And the second part is N2 plus 1 all the way to 50. Good. So now we are ready to set this equation using this information, right? Because this is the only information we have in the problem. Therefore, we are going to express the average of the remaining page numbers. But we express it in terms of the sums. As I mentioned in my other videos, whenever you have a problem related to average, you can always think about that in terms of sum. Then the equation shall look like this. First, we sum up these numbers, right? So that is a half times N1 times N1 minus 1. That is basically the sum of an arithmetic progression. And plus the sum of the second part. So if we call this is 1, this is 2, then this is basically the sum of 1. Now the sum of 2, that is a half times 50 minus N2 times, this is basically the number of pages after N2, times 50 plus N2 plus 1. And this shall equal 19 times, and this 19 is from the average, right? 19 times the number of pages. 50 minus n2 minus n1 plus 1. So now let's expand all the brackets and collect the terms. So first, we'll remove this fraction 1/2 by multiplying 2 on both sides. So we have n1 times n1 minus 1 plus 50 minus n2 times 50 plus n2 plus 1 equals 38 times 49 minus n2 minus n1. Some of you may wonder, why not I expand these brackets as well? The reason is because we only have one equation with two variables. So I don't anticipate to solve the exact numbers of n1 and n2 out, right? Therefore, this n2 minus n1 is related to the total number of borrowed pages. So I think that should be good enough. We should keep it for a little bit. All right, let's continue. So the left-hand side equals n1 squared minus n1. And this is from term 1. And from term 2, we just expand this, right? This 50 multiply each terms in these brackets. And the minus n2 times each term in these brackets, right? So let's just write it out. So that's 2500 plus 50 times n2 plus 50 minus 50 times n2 minus n2 squared minus n2. And the right hand side becomes, let's expand this brackets as well. We have 1862 minus 38 times n2 minus n1. Now let's collect the terms on the left hand side. All right, let's get some space. So the left hand side has n1 squared minus n1 minus n2 squared minus n2, then plus the sum of these two terms, right? These two terms cancels out. So plus 2550. That equals 1862 minus 38 times n2 minus n1. So first we notice one thing. So this is the square difference, right? So we can factorize that and get a term like this as well. Good. And these two can take a difference, right? So let's do it. So n1 minus n2 times n1 plus n2 minus n1 plus n2. That is from these two terms, right? We combine these two terms and have this. And then we move this to the left-hand side of the equation. That gives us plus 688. This is 8 equals minus 38 times n2 minus n1. And we want to keep this form because n2 is greater than n1. So we move this term all the way to the right-hand side of this equation. And some students may want to factorize this as well. Actually, that is also a good approach. It just gives a slightly different analysis afterwards. So if you are interested in it, I do encourage you to give it a try. It's virtually the same with a slight difference. Okay, anyway, we want to move this to the right-hand side of this equation and then combine with this term. So we have 688 minus n1 plus n2 equals n2 minus n1 times n1 plus n2 minus 38. And now let's express this on one side of this equation. We have n2 minus n1. That equals 688 minus n1 plus n2. And then divided by n1 plus n2 minus 38. And let's remove this term on the top because we want to simplify this expression. Therefore, that equals 688 minus 38 divided by n1 plus n2 minus 38, and then minus 1. This minus 1 is from this term. Good. So let's continue cleaning up. So this equals this 650 divided by n1 plus n2 minus 38 and minus 1. And if you want to move this minus 1 to the left-hand side, you have n2 minus n1 plus 1. Remember, this is exactly the number of pages borrowed, right? Remember, the pages borrowed is from n1 up to n2. Therefore, this is the number of pages borrowed, which equals 650 divided by n1 plus n2 minus 38. And up to now, I want to claim that we are already done with the calculation. So some students may wonder, why do you say that? Because we don't know the values of n1 or n2 at all. The reason is this. As I mentioned before, we only have one equation. There's no way to solve both variables out. And this is already good enough for our analysis. Because look at this. The left-hand side is the number of pages borrowed. Therefore, it got to be an integer, a natural number. So is the right-hand side. It got to be an integer. Right? So now we can factorize this 650. Then we know that both this and this shall be a factor of 650. So let's write it out. 650 equals 2 times 5 squared times 13 divided by n1 plus n2 minus 38. Up to now, you may have realized that the final part of this problem becomes a number theory problem, and that is exactly correct. Then we know that this one, n2 minus n1 plus 1, must be a factor of this number, which is 650, this number, right? This is the prime factorization of that. Then let's look at the question and the 5 choices. So the question is about the number of sheets, but that's okay. The number of sheets is basically n2 minus n1 plus 1 divided by 2, right? So it should still be a factor of this 650, which is 2 times 5 squared times 13. So let's look at these 5 choices. A, is this okay? Certainly not. Some of you may wonder, this should be okay, right? Because we have a factor of 2 and a factor of 5. But don't forget, we have to divide this number by 2 to get the number of sheets. Therefore, this 2 is already gone. Then A is wrong. B is certainly possible, right? And C, it needs a factor of 3 for 15. Then where do you find that factor 3 from this? Right? So that is totally impossible. And so is 17. Where is the factor of 17? 20? That is also wrong. It has 2 copies of 2. Where do we find those many 2's? Therefore, our choice is B. So this is our first approach. It requires some tedious derivation, but the method behind it is exactly the same as the second method. We'll see. Let's look at the second method. So in method 2, we don't want to set the variables as the pages because that's unnecessary. The question is about the number of sheets. To know the exact page numbers is entirely an overkill. Then let's look at this more straightforward approach. So we just set the variables as this. We just set his roommate borrowed n sheets, right? So this is a more straightforward variable. And therefore, we know that that contains 2n pages, right? And beyond that, we need one more variable. This is because in the problem itself, it only gives one condition. That is the average page number of the remaining. In order to write this equation out, we need to know the average of the borrowed pages. Therefore, let's set the average page number on the n sheets is A. Good. So now we are able to write this equation out. And again, we are not going to write the exact average formula. We'll turn that into the sums. So that is 19 times 50 minus 2n. This is the number of remaining pages, right? And 19 is the average page number of that. Therefore, when we multiply them together, this gives us the sum of remaining page numbers. And that plus 2n times A. This gives us the sum of borrowed pages. That shall be equal to the sum of all 50 pages, right? And that is this. That is a simple sum of arithmetic progression. So it's a 50 times 51. That is this number. So this equation is straightforward. Now let's collect the terms. Let's scroll down a little bit more. Good. Let's first remove this fraction by multiplying 2 on both sides. So we have 38 times 50 minus 2n plus 4na equals 50 times 51, right? So now let's expand these brackets and calculate these products. So 38 times 50, how much is that? 38 times 50, that is 40, 15 plus 4, that's 1900. So that's 1900 minus 72n plus 4na plus how much is this? That is 0525. Good. Then let's move this 1900 to the right hand side. Then collect these terms by factorize this n out. So we have n times 4a minus 72 equals this number minus 1900. So that is 650. Hold on a second. There's a typo here. This is not 72. This is 76. So let's correct that. That's 76. 76. Good. So now let's factor out another 4, because 76 is also divisible by 4. So let's do that. So this equals 4 times n times a minus 19, and it equals 650. And now let's factorize this 650 as 2 times 5 squared times 13, right? And we can cancel out a factor of 2 on both sides of this equation. So we have 2 times n times a minus 19 equals 5 squared times 13. So now again, we turn this problem into a number theory problem. And the reason is the same as the first method, because we only have one equation with 2 variables. There's no way we solve both variables out. Therefore, we can analyze it by using number theories, thanks to the fact that all these solutions should be an integer. Then we know that this n must be a factor of this, right? And now let's look at all the choices. Remember, n is the number of sheets, and that's exactly what's asked in this problem. It can divide 5 squared times 13. Good. So now let's look at the 5 choices. I'll use a different color. So this is from the second method. N can divide 5 squared times 13, right? So now let's look at A. A has a factor of 2, and there's no factor of 2 in this product. Therefore, A is wrong. B is certainly possible. C is wrong. We don't have a factor of 3 in this product. And D is wrong. There's no factor of 17. E is wrong. There's no factor of 2 copies of 2, right? This is 4 times 5. So E is wrong. Therefore, only D is a legitimate answer to our problem. If you like this video, please give it a like and subscribe the channel. If you have questions, please leave a comment.